I'm ready now.
Awesome.
So yeah, welcome everyone. I'm glad that you could join us today for this case study. We'll be doing more of these in the future. We're going to go ahead and get started right now. We're going to be sharing our screen to view the presentation. And I would like to start out also by saying that we will have some time at the end for any questions and answers. So if you have questions while we're doing the presentation, we may not be seeing them. You might want to just wait until the end and then post your questions. It may make it a little bit easier with the flow and to make sure we actually see your questions so it doesn't get buried in the list of comments. So I would like to suggest that there will be time for that at the end. In the meantime, we're going to begin the presentation.
Do you want me to share my screen?
Yep. Yeah, are you able to? Yep, go ahead.
Go ahead and see if you can adjust it on your side so that I can share. It says host has
distributed. Yes, it always makes me do this, even though it already says that one participant can. Oh, okay. Let's see, all participants. There we go. All right, here we go.
All right, we got it. Let me know if you see it.
Perfect.
Yay.
Awesome. So today we will be talking about that large EF4 long track tornado that happened in Ashby, or also some refer to it as Dalton, Minnesota, because it was actually right in between Ashby and Dalton. We'll be going over the data from that day, as well as a little bit of the forecasting that was happening before that event. This was a day in which the forecast didn't look super exciting or super promising for tornadoes. However, this significant tornado developed and was on the ground for quite a while. So it's a really interesting case to take a look at and learn what we can from what actually happened that day. I'm going to go ahead and
try and hold on.
Roll to the next screen there. And for anyone who is joining us today or watching this video a little later, because it will be available, we just want to take a minute to introduce ourselves, in case you don't know much about us yet. With the Twister Sisters team, Twister Sisters have been around for quite a while, and currently 2 active members are myself and Jessica Moore. Jessica's a fairly new member. Peggy Willenberg was a member of Twister Sisters, and she still is a Twister Sister and may participate in some things in the future, but currently she's not actively chasing. So just a little bit about myself. My name's Melanie, and I have a degree, Bachelor of Science in Chemistry and Biomedical Science. I actually double majored at St. Cloud State University. And while I was there, I also, actually after I got my degree, I went back to take additional classes in meteorology, and I studied photography there as well. I didn't complete my meteorology degree, but I did learn how to do forecasting and other critical things in the field of actually being out there to chase storms. I've been chasing storms since about the year 2000 in a serious type of way. I've always been interested in storms, always since I was a child. I wanted to see a tornado my entire life. Don't ask me why. It was just a goal of mine ever since I was a kid living in Arizona, where we don't get tornadoes. So finally, in the year 2000, I really got to know my stuff after learning some meteorology and how to forecast. I got out in the field and started chasing with other experienced chasers at the beginning. And since then, I actually met up with my other Twister Sisters partner back then, and we ended up doing some work for Fox 9 News in Minneapolis for a couple of years, as well as we had the Twister Sisters show on the Women's Entertainment Channel, which was a lot of fun, but a lot of hard work as well. And did a couple other documentaries. We're involved with other storm chasing projects over the years, including a National Geographic documentary. So it's really been a lot of fun, and I'm gonna hand this over to Jessica so she can share a little bit about herself.
Sure. Yeah, I'm Jessica. I've been chasing storms since 2012, but similarly to Melanie, passionate and crazy about weather since I was a little girl and watched Wizard of Oz for the first time. You know, I always just loved that opening scene with one of the opening scenes with the tornado, and was just enthralled from that very moment. That's really what initially sparked my fascination with tornadoes. But then growing up, you know, my dad, he had grown up in Texas, in Dallas, and he told me just so many stories growing up in Dallas of seeing tornadoes and one of which he watched from his rooftop as a kid with his brothers, literally demolish a gas station down the street and suck up the gas station 7-Eleven sign into the funnel. And so he had some pretty vivid, incredible stories of seeing storms when he was younger. So I was always just fascinated and interested in storms, but didn't really think of storm chasing as really much of a thing. I didn't think that was something people actually did until obviously Twister came out, and I was like, huh, people actually do this stuff. I wonder how I can get involved in something like that. I want to chase storms. And then, you know, it just kind of ended up unfolding naturally. We get so many incredible storms here in Colorado, especially May and June and into July with our monsoon season. So, I mean, I was just always out there with my camera, even before I really knew much of anything about meteorology. I was just out there always shooting, always photographing storms. And then, you know, eventually I did go to school, initially at Metro State University of Denver for meteorology. And then I switched to Mississippi State for my Bachelor of Science in Operational and Broadcast Meteorology. So that's where I ended up actually graduating from. Professionally, I've been chasing storms since 2012, and then worked previously for Weather Nation TV as a field correspondent. I've been on multiple, my footage at least has been on, you know, pretty much every national network as far as documenting weather goes. So just a lot of fun there. And then, yeah, and then Melanie approached me fairly recently this year. I think it was August, and I think August timeframe, was like, hey, you want to partner up? Peggy's kind of pulling back the reins and not really going to be involved as much anymore. And I was 100% on board because I've heard of Twister Sisters for years. So I was very excited to partner up with Melanie. And so it's been pretty fun so far. We've done a lot of cool things already. So we're excited for 2021. All right. You want to talk about this before I play it?
We are just going to start out here with a little clip of the tornado from this day that we'll be talking about right now. And just as a heads up, since we're doing this through video chat, through Zoom and Facebook, there may be a little delay or choppiness in the videos that we play. We're going to go ahead and play a little clip of this tornado. This was actually as it's crossing the road. Across the road right in front of Brad and I.
Oh my
See the debris? Look at that.
Yeah, unfortunately, some structures got hit.
Incredible motion.
Yeah, I just couldn't believe how close we were to this tornado. It was incredible, especially at the beginning there. And it was moving very slow, as I'll mention in a moment. But yeah, just some clips. This incredible photogenic tornado that was on the ground for over 30 minutes. It was pretty unbelievable.
Even though you said it was.
If you want to see more of this video, you can see some of it on our Facebook page in our videos section, and also on our YouTube channel, which is Twister Sisters.
So I want to comment real quick, because even though, like you said, the forward motion wasn't that fast, it was still like incredible motion in that little drill bit there. Just in that portion of that clip was just incredible.
You sound a little quieter, Jessica, than you did before.
Can you hear me?
I wonder if it's because of the video. Just letting you know.
Can you hear me?
I can hear you.
Like,
for some reason, it got a little quieter.
But is this better?
Let's see what other people have to say. Can you hear Jessica okay?
Hello. Because I can hear you great.
Okay, good. Tim says that you're not coming through very well.
Okay.
Your audio. It's like the audio switched when you hit play on the video or something.
Well, I don't really know how to change that.
I can still hear you, but if you get, closer to the microphone, wherever that is.
Let's see.
Kevin says he can't hear you. And Matt says he can hear you, but it's just quieter. So maybe just speak a little louder. I'll be talking about this portion also, if you want to take a look at your computer for a second. So yeah, to get started, this was the damage path, the official survey from the National Weather Service of the tornado that passed between Dalton and Ashby, Minnesota. as you can see from it, hopefully you're watching this on your computer instead of your cell phone, but if you are looking at a small view, you might not be able to see the details here. This tornado was on the ground for 9 miles and 31 minutes from 5:08 p.m. until 5:39 p.m. And at its strongest point, it was rated an EF4 tornado with winds up to about 170 miles per hour. And at the max width, it was only 650 yards, which, as Jessica mentioned, it was what we'd call a drill bit tornado much of the time. Just really strong wind speeds, but in a real narrow vortex. So sometimes we call that, in the chasing world, a drill bit tornado. Unfortunately, there was one person who was killed in this tornado and 2 injuries. It did hit a machine shop, and there were 2 people actually watching it come towards them, and they didn't really realize it was coming right towards them until it was almost on top of them, and then they each chose a different place to take shelter. One person went inside the machine shop, the other person went underneath the tractor, and unfortunately the one person was killed who went under the tractor. So that's kind of a reminder for many of us, even as a chaser, sometimes we can get mesmerized by that tornado and, taking pictures of it, recording it while it's coming straight at us, and not really remember how dangerous it can be. Like, as it's coming towards you, it might be there really fast. As we know, tornadoes can accelerate quickly. They're a little bit unpredictable. So it's always good to be more aware and be sure you get out of the path or take appropriate shelter before it's too late. So this tornado, it was interesting on this day. If you want to go, can you go back to one real quickly? I want to mention that earlier in the day, on this day, there were 3 tornadoes in the same area near Fergus Falls, Minnesota. And I was surprised when I heard about this because it's not a typical thing, first of all, to see many tornadoes early in the morning. And it was pretty early. There was the system that came through earlier was a QLCS, or quasi-linear convective system. And it actually ended up producing 3 tornadoes in that area. 2 of them were EF1s and 1 EF2, which was surprising because that's somewhat strong. And one was actually quite close to the Fergus Falls airport. And we don't hear much about those tornadoes from earlier in the day because this one that happened later was way, a lot more significant. And that's what everyone ended up talking about. Okay, let's go ahead. Here's just we're going to share a couple pictures of the damage that was done. These photos are from Gregory Gust, who works at the National Weather Service in Grand Forks. He was actually out doing damage surveys of the morning tornadoes when this storm developed. He was already in the area surveying from the earlier storms, which was interesting. And as you can see here, pretty significant. This was the strongest point, the F4 wind speeds. There was a house here and it's no longer there. And there's a car, blowing into the basement. It's just incredible to look at, again, the damage that can be done, and to really, actually this is kind of scary when you think about it, because that house is just completely gone. So even if you were trying to take shelter in that house, probably wasn't a good place to be. All right, next photo. And this is just a great image from the air of the scar that the tornado produced. There was a lot of talk about how the scouring from this tornado was just incredible, just what it did to the earth, because of how strong it was. Keep going. All right, let's see how.
Okay, how do I sound?
Sound better than you did. Yeah.
Okay. Clear enough? I tried to switch it to my better microphone.
Yeah, you do sound better.
Okay. Well, I guess just briefly wanted to kind of give my perspective, as I had been chasing the previous day in southeastern Wyoming, and was kind of analyzing the day 2 discussion from the SPC and just kind of weighing the pros and cons of making the long haul out to Minnesota. There was a day 2 slight risk from Nebraska to Minnesota, 5% initially tornado risk in central and southern Nebraska. We were seeing ample CAPE and moisture, but we were concerned about early morning convection delaying storm initiation until closer to dark. Also noticed that the better upper level support was displaced further to the west. So we had our better vertical shear lagging behind the front. So kind of a lot of questions of, a lot of uncertainty regarding, well, our storm's going to be linear in storm mode? Are we going to have outflow dominant storm structures rather than isolated and organized? And there was just, is that early morning convection going to clear out in time in order for the atmosphere to recover in time for storms to form before dark? And it just seemed like really kind of too much uncertainty to really gamble on that long haul out east to Minnesota. So ultimately decided not to make that trip, much to my later regret. But I just wanted to quickly show the 6Z day 2 outlook initially with that 5% over central Nebraska and Minnesota.
Yeah, it's really interesting to point out how early, the day before, it looked like the better place to be for tornadoes even would be in south central Nebraska, not up in Minnesota.
Not even in Minnesota, yeah.
At least according to the Storm Prediction Center outlook.
Mm-hmm. And then even just wanted to show quickly the text from SBC day 2, which also talked about the better vertical shear kind of being displaced further west and just not having that sufficient upper level support to really keep storms organized, as opposed to just quickly having storms undercut by the cold front and lining out and just kind of not being altogether very organized. So just a lot of questions there.
Right, and as Jessica mentioned already, I don't have to say too much more, but from my perspective, I was already in Minnesota. And I was definitely going to chase because I was getting out there as much as I could this past year to chase as many systems as I could. But I wasn't too excited about the day. It looked like more of a cold front situation with more clusters of storms, and generally you see more linear storms along the cold front. There was some shear that was expected in the environment, but because of some questions about earlier convection clearing out and other things, and cold front setup, it didn't seem too exciting. And I actually, at one point I was a little tempted, like, should I go to Nebraska to chase? But since I'm in Minnesota, I thought, yeah, I'm definitely going to go out and chase in Minnesota. And it looked like there could be a low pressure way up on the border of Minnesota or into Canada, but we weren't really expecting a low in our area initially on this day. And as Jessica mentioned, so at the 1730 day 2 outlook, she was looking at the 06Z, the earlier outlook. Now we're looking at a little bit later. And in this next outlook, the Storm Prediction Center didn't even mention tornadoes in their text. And as a chaser, when we see that, we get a little disappointed sometimes. It's like, oh, only strong wind gusts and severe hail. But I was still going to chase. And here's that outlook, the next day 2, which again is the day before. So this is at 12:30. Still a slight risk. Now they've even downgraded that probability of tornadoes to only a 2% along that boundary. And it didn't look any better according to the outlook anyway in Minnesota versus Nebraska. In fact, it's starting to look a little better up here. All right, keep going. So we don't need to go through any of this text here. And this just a quick look at one of the models that we tend to look at the day before we chase and the day that we do chase as well. It's the HRRR or the HRRR, the high resolution rapid refresh model. It's a convective allowing model, meaning we can see when this particular computer model thinks that convection will happen and where and kind of how it looks. Is it looking linear or more supercellular? So this was from the day before the 18Z run of the HRRR, and as you can see, it actually looks like a little better storm popping up there in the border of Nebraska and South Dakota along that expected boundary in that area. But we're not seeing much at 4 o'clock. This would be for 4 o'clock on the chase day, yet popping up according to the model run, which of course models are not always right. It's just another way to do some forecasting. If you want to go ahead to the next slide, we'll take a look at 5 o'clock. And again, more storms popping up down there in Nebraska. Sometimes when you've got more of a cold front type of boundary, it's sometimes better to be on the south end, the tail end Charlie of those storms. So according to this model run, it almost looked more interesting down in Nebraska. So it wasn't, again, not getting too excited, but at least according to that. Now we're going to dive into some of the actual data on the chase day and what really did happen in the environment that came together to produce this amazing storm.
Okay, so typically with forecasting, I like to kind of start with the top of the atmosphere and work my way down in terms of looking at the upper air analysis, and that's pretty traditional. So I wanted to start with kind of looking at upper air charts, 300 millibar chart here for 0Z on the 9th, which would be 8 o'clock, or I'm sorry, 7. So what I wanted to just show was just really kind of starting to see some divergence here in the upper levels. When you have winds that are accelerating away from each other, that's divergence. And so you see this 60 knot, might even be 65 knot wind barb here, accelerating away from the 40 knots here. So we're seeing the yellow kind of indicates pockets of divergence. So that essentially creates a vacuum through which upward moving air parcels want to try to, rise and fill that void. So it's just promoting uplift in the environment. And kind of similarly, working our way down in the atmosphere to the 500 millibar level, starting to see, here's that trough kind of moving through the region. It's a little bit negatively tilted here. I'd probably draw the axis about right here. And we have kind of in the right exit region of this trough, we have winds kind of moving away from each other. So that's diffluence here in the 500 millibars. So 35 knots, 50 knots over here. So winds kind of diverging away from each other in this area. Moving down to 700 millibars. Again, we're seeing that trough up here, and really wanted to kind of show this area here of moisture pooling, which is actually in the vicinity of a mesolow that develops later this afternoon. This is 0Z, but it actually really started to develop earlier in the afternoon. So we had a little mesolow here and moisture kind of converging in that region. And we moved down to 850 millibars. And this is really where you're starting to see kind of the moisture advection pulling moisture northward into the area. And again, you can still see the moisture pooling, especially right here in eastern South Dakota, kind of, again, pulling that moisture north and northeastward into the region, into Minnesota. And this is some surface analysis. This really gives us a better idea of what's going on at the surface. And so here's that mesolow developing that I kind of previously alluded to. You get a better visualization of it here. And a wavy warm front kind of extending across Minnesota and northern Wisconsin, cold front draped across southeastern South Dakota into central Nebraska. And then what I really wanted to point out here, you can really get a better visual of how much moisture, how good our moisture is that's advecting northward into Minnesota. I mean, dew points in the low 70s, and even in southeastern South Dakota, you can see dew points of 79, so almost 80. And so incredible moisture really being pulled northward into Minnesota in the vicinity of this mesolow here. So this is going to be kind of our area of focused enhancement that we're going to be looking at here in a little bit, but just wanted to show a couple little composite parameters. Sig Tor, just kind of showing a few little bullseyes here, central Minnesota and over here as well, in southeastern North Dakota, northeastern South Dakota. And this is all 0Z, so even 21Z, some of these parameters are actually higher, but this just at least gives you an idea of just some of the composite parameters, what they're showing for the 0Z time frame. SRH values, 150 meters squared per second squared in central Minnesota, but that was actually a little bit higher earlier in the afternoon. So we're gonna look at some soundings here to get a better visualization. So I wanted to initially look at the 12Z sounding from Aberdeen, South Dakota. So this is 12Z observed. And I just wanted to quickly point out a few things, and no worries if you don't know how to really interpret these soundings. I'm just, for folks that do follow at least, have a general idea of how to interpret these, I just wanted to quickly pull up a few soundings. So again, this is.
And I just mentioned real quick, yes, how soundings are really important to just be able to see what's going on in the atmosphere at all different levels. So yeah, if you don't understand what soundings are or how to read them, again, we're going to be doing some classes and some mentoring sessions. So it'd be great if you want to join us to learn more about these products and how we do this forecasting and what some of these terms mean.
Exactly. Yes, ma'am. Exactly. So for those that do know at least a little bit about data analysis with these soundings, first couple notable things here is a strong mid-level inversion here. This is pretty typical for early in the morning soundings, but surface dew point already at 62 and surface to one SRH values are incredibly high, almost 270 meters squared per second squared, and shear of 15 knots in the 0 to 1 kilometer level. So that's just incredible low level turning of the winds. Essentially, that's what shear is. It's just changing wind speeds and wind directions. So, and you can see that here by looking at the wind barbs, how they are strongly shifting and veering just in that low level, just really strongly shifting from almost like northeasterly all the way up to southeasterly there. So just incredible shear already in that early morning observed sounding. You can see the kink in the photograph here, kind of visualizing that. And then later in the day, 0Z from Minneapolis, this observed sounding from Minneapolis, shows you just the incredible amount of CAPE, even like surface-based CAPE, almost 5,000 joules per kilogram. So this is just essentially the amount of instability in the atmosphere. This is the propensity for air parcels to want to rise up and become buoyant. So, and then, but typically we kind of want to look more at the mixed layer. So mixed layer CAPE is showing 2,800 joules per kilogram roughly. Not as strong of shear in the lower levels in this vicinity, but we are a bit displaced from that meso low. So we're a little bit displaced from the stronger forcing, but regardless, it still shows you just the incredible amount of instability in the environment that day. And another thing too, I want to know is just this mid-level drawing. This, you know, and again, don't worry if you don't know exactly what I'm talking about here, but the mid-level drawing is essentially this sharp decrease in the moisture at about the 700 millibar level. It has been kind of indicated just from talking to some other folks that that might be a contributing factor as to why that tornado was so photogenic and why you had such clear visibility of that tornado from basically all angles. I don't know a whole lot. I can't speak a whole lot to that. But that's just something I've been chatting with we've been chatting with some other chasers regarding. So anyway, just again, still strong low level shear, even here, 20 knots for 0 to 1 kilometer level is still pretty good. So, and very high surface dew point, 72 degrees. So lots of moisture in the atmosphere, tons of instability, just incredible amount of moisture advection, again, into that region. So these are all kind of contributing factors as to why, you know, you just really had this environment that was so primed. And all it just needed was a little bit of extra forcing, one little extra ingredient, which just so happened to be present in the form of a outflow boundary that was present from the early morning convection that had moved through northern and central Minnesota. I mean, you can see this outflow boundary here just kind of draped across southern and central Minnesota. And actually over here is where storms really started to kind of blow up in this area later on, you know, and basically in the vicinity, it kind of made a focal point for enhanced convergence for storms that would later develop in that vicinity of that triple point and mesolow that developed that afternoon. So for this part, I'm going to actually I'm going to stop my share screen and I'm going to have Melanie take over.
All right, we'll just pick back up where we were here. Give me 1 second. As Jessica was saying, that outflow boundary is really one of the key factors from this day and what created this incredible tornadic supercell, because it provided more of a warm front situation, and we had the intersection of boundaries, the mesolow present. All these things started to come together for an incredible storm. Here we're just taking a look at the radar composite. If you want to talk about this, Jessica, I'll step through it. So right here we've got, yeah, go ahead. This is earlier in the day. This whole big mass is early in the day.
Yeah, exactly. So this is our morning convection that is moving through. You'll see it's slowly progressing. Go ahead. And it's leaving essentially an outflow boundary in its wake. You can see it Let's see if I can't show my pointer, but yeah, you can see it.
Oh, yeah, right through here.
Yep, there you go. Yep, you can see it already taking off right there. And with that visible satellite image from the slide before, you can really see just the better visualization of that. But as you can still see it there. That's just that outflow boundary kicking off from that morning convection.
And now it's clearing out. And sometimes when we chase, we don't know. And with forecasting, what is going to happen from that early morning convection? Yep. Is it going to leave? Is it going to clear out? And will there be enough insulation, enough warming after that clears? Or is it going to leave a cold pool and prevent good convection later on in the day? Mm-hmm. All right, if you want to go ahead, and we're getting into the afternoon convection here now.
Yep, so you can see just right there in that little kink, you can see storms starting to fire later in the afternoon. And then honestly, you'd be better talking about this part because you were actively chasing at this point. So
yeah, I'm just playing the loop here. You can see the whole day.
Right there, boom.
Yep. We'll stop it. And we have another image later on. So we just want to like give you an idea of what that day looked like. A lot of convection that came through early in the morning. Again, it was a quasi-linear convective system, meaning, and there were tornadoes with it actually. And then it luckily cleared out in time for the afternoon storm development.
Chase data. Ooh, the fun stuff.
Yeah, now we're gonna go ahead and take a look at just some of the parameters and some of the things that we look at as chasers on the day we're chasing. Day one means the day of the chase, basically. This is the day. And in the morning, well, actually, this is by 11:30 already, 1630Z, they upgraded the risk to an enhanced risk for severe weather. Storm Prediction Center did, down in Nebraska. So if you just looked at that, you would think you might want to chase in Nebraska. However, that enhanced risk was more for hail and strong winds, whereas they actually changed the tornado graphic quite a bit based on the environmental parameters and didn't even have that 2% anymore down in Nebraska for the possibility of tornadoes. But it's interesting to note there actually were some tornadoes down there in Nebraska as well. And I know there are a couple chasers who saw those. They weren't as significant as what happened in Minnesota, but there were some down there. As you can see, they now had a 5% probability of tornadoes in Minnesota, but more to central and eastern Minnesota. And where we saw this tornado by Dalton and Ashby actually was just outside the 2% graphic. So you don't want to just go right to the middle of these graphics when you see a 5%, you don't want to go sit in the middle waiting for tornadoes because that's not necessarily where you should be. All right, so and in their text for their day one outlook, they were now actually talking about possibility of tornadoes. There's enough low level shear and a lot of instability and moisture, but there was still a little uncertainty about what exactly would happen. All right, so I wanted to give an idea of where on this chase day. So I chased with Brad Nelson, who's a meteorologist and a friend. He's a great meteorologist and a great chaser. He chases with Silver Lining Tours. We decided to team up on this day. Sometimes we get together for a chase and it's always a lot of fun. And we were still kind of curious what's going to happen with that morning convection clearing out. And we didn't feel like we were in too much of a rush because it looked like storms were not going to develop until a little bit later in the afternoon, closer to 5 or 6 p.m. So we didn't feel too rushed to get to our target. We knew we needed to get north and west. And honestly, I did want to just head up 94 towards the Fergus Falls area. And when we're chasing, we're always looking at data. We're looking at updated model runs, updated Surface Obs and the satellite to adjust our target because we don't always end up at where we initially thought storms would develop that day. So we talked about things and we even considered having a sit down lunch, and I'm glad we didn't because we barely made it to our target before that storm initiated. Well, the blue line indicates the route that it would take from my house to Fergus Falls, which is only about 2 hours and 30 minutes. But because of the situation, we thought maybe storms would develop a little later. So in that case, all the parameters would have shifted a little bit further east. So we didn't want to end up going too far west and then have to backtrack, because that just sucks, a lot of driving. So we ended up, instead of going directly way out here, we went on this, where these red arrows are pointing roughly. We went a little bit more north, just kind of took our time, kept looking at data, what's going on, what's happening in the environment. And honestly, I remember with each run of the HRRR this day, it kept pushing convection a little bit earlier and a little bit further west with each run. So we're kind of wondering, oh boy, it looks like, you know, maybe things are going to develop a little further west. So we ended up finally heading out towards Fergus Falls, and also based on surface observations, saw a low developing. This was at 2 p.m. I looked at the surface obs, I distinctly remember this, and I said, it looks almost like a low right there, because there's a little bit of a circulation, if you can see in the wind barbs here. But I was like, I don't know, but it looks like kind of low. And sure enough, there was a mesolow developing, which is always good when you're a chaser, because it's an indication we might see something more interesting. You usually have more shear, more rotation in your storms that are near a low pressure system. And because of that outflow boundary, which you would look for the outflow boundary on here based on wind shifts and the wind barbs. And it was kind of an odd shaped outflow boundary. It became more of a warm front with all this warm air advection from the south. But this was right at 4 o'clock, right before the storm developed. That low was right near Fergus Falls. It's a triple point, actually. We've got the warm front and the cold front coming off that low. And it's always fun to look at the graphics that the Storm Prediction Center puts out when they issue their mesoscale discussion, because they are the experts. They do this 24 hours a day, and they are really good at it. I like to think I'm pretty good myself, but you know, it's always, they're sitting there doing this all day long, looking at data, and are very experienced. So I was happy to see, yes, there is a low they're indicating here. And as you can see from their analysis, their very detailed analysis, that outflow boundary warm front, as they're calling it, a modifying outflow boundary and warm advection zone, was real wavy looking, not your typical, just real obvious warm front. And surface trough is coming in. They've got a lot of information here at different levels in the atmosphere. But they've issued this mesoscale discussion, and as Brad and I were moving out in that direction, we're like, oh boy, we do have to get west. I mean, these things are really coming together, and if storms fire a little earlier, we want to be there. It's important to be there for initiation, especially on a day like this. Oftentimes it's that first storm that becomes the most interesting, because as more storms develop later on, you get more merging and not as interesting structure. So in the discussion here, they were talking about surface analysis showing the low, as we can see in the graphic. Supercells are possible initially with modest southwest winds aloft and low-level winds veering with height, aided by the outflow warm advection zone. So the greatest tornado threat is expected across north central Minnesota and towards Arrowhead through the evening. Large hails possible, damaging winds. Still, it didn't sound like too exciting for tornadoes, even though we're getting a lot closer to initiation. And we were getting more and more hopeful, Brad and I were, that we could possibly see a brief tornado, because we've got more of these parameters actually coming together the closer we get to initiation. Sometimes it goes the other way and things just get worse. That cap is too strong, you know, nothing can form, storms can't develop. But on this day, things look like they're coming together nicely. And they ended up issuing a severe weather watch at 4 p.m. They never did issue a tornado watch. Again, that's why this is kind of an interesting day to look at, because there was no tornado watch, and yet we had this really significant tornado develop. Here's a nice satellite loop from NOAA. It was on their website page, and they encouraged people to download it as long as we give them credit. But it's a nice look at that storm going up, and this is why as a chaser we love to look at satellite, because models can give us an idea of what they think it's gonna happen based on the parameters, but what's really happening is most important. So we could see on satellite, actually at this point Brad and I were just getting into Fergus Falls right when we saw that tower go up on satellite. And as you can see, more storms developed. There was actually another tornado further east with one of the other storms that developed on this day. This is cool image. So at 4:32 is when we were at the gas station. Again, good thing we didn't stop for a sit-down lunch on this day. When we got to the gas station, we did not see anything yet showing up on satellite. And of course, satellite, there's a bit of a delay. The best you can do is look at the sky. What do you see in the sky? Because with satellite, you've got some delay. With radar, you even have a few minute delay. So we pulled up to the gas station. Brad ran in to get some pizza. And I said, I think after we get some gas and some food and go to the bathroom, we're going to see something start to go up. And sure enough, we looked at satellite and saw that tower popping. And I'm like, that's just right, just south of us. But we couldn't see it because the building was in our way. So as soon as we moved away from the building, there it is, that nice updraft. As you can see, there's so much moisture in the air this day. We have some other low-level clouds, and our view is not crystal clear, but you can clearly see this nice, really good-looking, robust updraft. We knew that was it. That's the storm we have to get to. And luckily, we were only like 5 miles away from it. And on radar, this is all it looked like. This is, again, that composite radar image. There's a tiny little green yellow dot on radar at 4:25 p.m. And this is an interesting image to look at because we can see where the radar sites are. These blue, returns here are radar sites. So this storm actually popped up in what you'd call a radar hole. There weren't any radar sites very close to this storm. So it was harder for the National Weather Service, for meteorologists to be able to read what is actually happening with that storm just based on radar. Since it was so far away, it's harder to see the low levels in that storm. Because of that, initial reports and ongoing reports from the storm, from chasers as well as spotters out there, were really critical for the National Weather Service to know what was happening and be able to issue those early warnings. And they did a good job. They really got the warnings out because this storm went up and that tornado came down like within 45 minutes. It was fast. It all happened really quickly. The initial tornado touched down again at 5:08 p.m., not long after we saw that tower go up. Just taking a look here at a couple of the radar images from the day. And again, it wasn't too close to radar, but we can still see the couplet on the velocity. Here you can see it's right again between Ashby and Dalton. So people will argue, was it the Ashby or the Dalton tornado? And right here, we're looking at reflectivity. And we don't see that classic hook that you might see on the storm if it was actually closer to a radar site. Any comments you'd like to make here, Jessica?
Yeah, I mean, I just would be curious to see what that storm would have looked like had it been closer to a radar. Because again, like you said, it's just not resolved very well here because again, so far from any radar site. So sometimes you just have to work with what you've got, and that's why it becomes that much more important for the field data, for the field folks in the field to be, like you said, delivering reports.
Yep. All right, so as far as positioning, while I was chasing this storm with Brad, it's always interesting how we end up positioning on storms. Oftentimes we want to be on the south, somewhat east side, depending on the motion of the storm. You don't want to be directly in the path of the potential tornado or the mesocyclone, but you do want a good view of it. So oftentimes on the backside, you've got rain wrapping around and you're not able to see into that mesocyclone. In this case, Brad and I were coming in from the north, and since that storm was moving northeast, we didn't see anything happening yet, so we stopped for a few minutes to take a look and wait for it to just move closer to us. Why do we need to keep driving if it's moving our direction? So that's always a good time to stop and take some pictures. And you can just see here, there's kind of a rounded, it doesn't look like a classic mothership supercell. Again, there was so much moisture in the air, low levels at least. Things weren't super clear, but you can see there's a nice wall cloud. This is to our south, so we're looking south from the north. And I actually posted a picture, and some other chasers recognized right away, wow, that's really got a nice bowl shape to it. I guess it does, but at first it didn't really stand out to me like the best looking wall cloud, but it's there. Like right away, we've got this nice wall cloud developing. Oh, all right, I've got a little slideshow. So shortly after, really quickly, a funnel started to develop. And this was definitely, sometimes you can't tell if it's a funnel or if it's a little bit of a scud finger type thing. But in this case, it really looked like a funnel. We weren't quite close enough yet to see the rotation. So sometimes as chasers or spotters, we get hesitant to report it to the National Weather Service because we don't know for sure if there's rotation, if we can't see it. But the way that this looks, I mean, I made sure we called it in. Brad actually called it in and reported a funnel halfway to the ground, even though we were not able to confirm rotation. But there were other people who were calling it in too, which was great. As we continued to watch, we ended up, driving a little closer because we realized it was moving so slow. Oftentimes storms are moving a little too quickly and you don't have much time to stop because your road doesn't follow the storm exactly as it's moving. So we did drive a little more south, got a little bit better positioning under that mesocyclone. And a tornado came down. Clearly, it's on the ground at this point, and there's actually debris. And so I like this shot because it's me with an umbrella, and this was a picture Brad took, photo by Brad Nelson, which is a really cool shot, just that nice action shot with the rain started coming in. Because that's why also we like to be on the south side, because then we don't have to deal with the rain, but we were still on the north side. So it was still coming in our direction, but we did feel that it was not gonna come directly at us based on our position. However, the rain started to move in and obscure the view and just get my camera wet and all that stuff. But I didn't want to move because we had this incredible tornado right in front of us. Finally, when the rain got so heavy, we're like, okay, we gotta reposition. It's just a little too intense now. Again, just the view from, you can see the rain in there. So we got a little closer. My throat's getting dry. And this is like just an amazing view of the tornado, I have to say.
Incredible debris.
Right, that debris cloud, oh my gosh. I honestly have never seen anything like it in my 20 years of chasing storms. So this was like an unreal shot, and it was moving so slowly. We just stood there for it seemed like several minutes. I don't know how long we were actually right in that position, but we had time to just watch it. Excuse me. And it had moved across the road, and then we knew it was moving away from us at this point. So we were safe in a good position. Excuse me, my throat's getting dry from talking in this cold, dry weather here in Minnesota.
Yeah, no fun at all.
Yeah, so I just can't believe what we were seeing right in front of us. Unbelievable. And then we had to get in our car and keep following it. There were some chasers who got a lot closer than we did at this point, and they have some incredible footage, like Michael Martz and even Scott Peak. I know there's some great footage out there. Tanner has some amazing footage as well.
Mm-hmm.
Bill Domes, a lot of people were out there. There were some chasers though, that I hate to say showed up just a few minutes too late. Oh, that must have been tough.
The worst. The worst feeling ever.
Right? So as we got behind this tornado, we were following it, and we were no longer in the rain. We're in a better position, and the sun was shining. It was just incredible. As you can see, we've got a rainbow here showing up. It's like a dream come true as a chaser. And at this point, the tornado, it appears to just be out in the field, which was good. You know, that's how we prefer to see it, not hitting a city or any structures. Oh, got a little video here. Again, the video might be delayed on the Zoom. But if you want to see the video, you have the full chase, raw footage actually also, which is over 30 minutes of the chase.
Mm-hmm.
Which really gives you an idea of what it's like to be out there chasing and really trying to decide whether to stand there and film this tornado or get a little bit closer. should turn my volume down. Wait. So, yeah, this tornado, this was the rope-out phase right here, which I just love. It's just beautiful, that clear, translucent looking vortex, and then little rope. And here's a wider view from the GoPro, which is fun. It's so much fun to be able to have both views, having the GoPro and also camcorder zoomed in a little bit right on the tornado. But I love, this has always been one of my favorite things to watch, are time lapse of cumulonimbus clouds, and just watching that motion, and it's just beautiful. Yeah, what a day. This was quite the day. All right, and this is what happened. We had that tornado here where we were near Fergus Falls, Dalton, Ashby area. One more tornado further east. There actually was someone locally who had a picture of that. And then, as you can see, there were a few tornado reports out here in Nebraska. From my understanding, they appeared to be more of a landspout type tornado, but not as big of a tornado as here in Minnesota. Excuse me. All right, so we're just going to go over a summary of some of the key factors from this day. Again, we mentioned, both Jessica and I talked about that outflow boundary, which enhanced that low-level shear, created a better environment for tornado development. Excuse me. Those winds were more backed as a result of the outflow boundary. It creates a little more lift, and it created more of that triple point with that warm front type of setup instead of just a cold front with more linear storms. The atmosphere was able to recover better than we expected. You want to talk about this, Jessica?
Yeah, you know, it's always just so challenging to try to, I guess, anticipate, you know, how quickly is the atmosphere going to recover from that early morning convection, because that early morning convection can make or break a chase day. If it's too much, if it doesn't clear out early enough or quickly enough, you don't have enough time for that adequate insulation to really build up the instability and erode some of that, you know, capping to allow storms to really develop and mature. So it's really challenging because it's just hard to really know whether or not the atmosphere is going to recover enough that storms are going to be able to sustain themselves.
All right, yeah, and so really, though, I mean, there are a lot of reasons why this storm developed and that tornado formed. These are a couple of those key factors that did come together on a day when previously, even just the day before, we didn't see this coming. We didn't know that that amazing alpha boundary would set up perfectly. We didn't know that the morning convection would clear out and that mesolow would be there. It was really, as someone pointed out, it was I guess this is one of Chuck Doswell's quotes along with somebody else. It was a happy little mesoscale accident. Exactly. So yeah, and honestly, a lot of chase days can be this way. A lot of severe weather days can be similar in that, first of all, it can look like not that big of a setup and turn out to be something like this, a lifetime tornado, like the most incredible tornado you might see in your entire career of chasing. Or it might look like a really big day, days that they sometimes call the cap. It's boom or bust. It could be an incredible single supercell moving across the plane, producing more or multiple tornadoes. But if that cap doesn't break, if those upper levels are too warm and we've got that inversion that and nothing comes in to cool off, you might not get anything until after dark and then just a lot of lightning. So it can go either way, really. That's why you just got to get out there, and if you want to see storms, if you want to chase, or if you want to do some spotting, it's important to just get out there every chance you get and learn from each time you're there, whether it's a great day like this or if it's a bust. Believe me, I have my share of busts as well.
Yeah, it's painful for sure, especially sitting back and watching this unfold from Colorado and being like, well, I probably should have made the grind all the way out there. I mean, it was painful. It was definitely painful at the time, but you know, once you've been chasing long enough, after a while, you just get used to just knowing that you're going to miss events, especially if they're far away and it's a big risk. It's a big uncertain. There's like just too many uncertainties for you to really be willing to pull the trigger and make that long drive out there. I mean, if you have the means to do that kind of stuff all the time, then, you know, and you can chase everything all the time, then, you know, you're going to see a lot more incredible storms and tornadoes. But some of us have to be a little more selective about when we chase. And unfortunately, this was a scenario that I did not really have the means to go out there. I mean, I probably could have, but it really just didn't make sense for me to make that grind. And even then, it was just too much uncertainty. And then, of course, I ended up watching that and regretting it so badly. But, you know,
Well,
again, it's just, I know I'm not the only one. I'm far from the only one that missed that setup and did not chase it because of those uncertainty factors. So,
right. And like you said, you know, that week, a lot of people were chasing the high plains. There were a lot of people out there already way out west. And to come to Minnesota for one day and then get back west for the next day, that's a lot of driving, and it better be worth it. And with the forecast the day before, there was just no way to know. It did not look that interesting, not interesting enough to drive that far for one event.
right.
I got lucky that I happen to live in Minnesota because
That helps.
I wasn't interested in driving that far either. So not based on the forecast anyway.
Right.
You know, it's like the closer and closer we got to initiation, the better and better things started to look. It was something you couldn't really forecast that far ahead of time.
Nope, exactly. And like you said, you know, not over relying on models, and really, you know, the models are there to be a great resource to kind of give us an idea of trends and patterns and things that we can kind of look for in the overall forecast that might indicate a day of, you know, potential that we might see some good storms and tornadoes. But really, it's not until the morning of a chase that you're looking at mesoscale analysis, and you're looking at satellite data, and you're looking at observed soundings. And again, that surface analysis is so huge, because so much of, you know, what components need to be there in order for tornadoes to form is in the mesoscale and microscale, really. So a lot of that you just can't know until even sometimes a few hours before a storm develops. So it's just important to not become over reliant on models and really do a lot more with the day of nowcasting, with the you know, the satellite data, and really just read the atmosphere. What's the atmosphere showing you? That morning, all you had to do was look at that, you know, that, I should say later that morning, that outflow boundary to know, oh, okay, well, storms that can form in this vicinity or in a prime environment, then you have this outflow boundary here. So, I mean, this could be a big day. So,
yep. And as I mentioned earlier, one of the lessons I learned on this day was do not sit down for a long lunch. Not until you're at your target anyway. Because if we did that, we would have missed at least part of that tornado, maybe the entire thing. And I know there are chasers who, like I said, some showed up a little bit late. They showed up right at the end. And that is so frustrating on a storm like this. So yeah, get to your target earlier, and that target might shift and change as the day moves on. You might have to drive a little bit further east or west, north or south. Just keeping an eye on that data, that continual updates of those surface observations, watching satellite.
Yeah. Can I ask you a quick question from Wesley Beck? He wants to know, when you were at your closest to the tornado, what was the sound like?
You know, it wasn't that far from us. I don't know how far it was, but we certainly were not as close as Michael was. But we were definitely within a half a mile from that thing, and pretty close at one point. As you could see, the debris was right in front of us. And when I first stepped out, it just sounded really windy, to be honest. I mean, it didn't, maybe a little bit of that roar, but it didn't sound like a freight train. It wasn't like that. And I mean, again, it was a pretty narrow tornado. So I don't know, it probably sounded different if you were right next to it, but it was definitely a strong tornado. But I'm curious, you know, what makes it. Yeah, I didn't hear the freight train, just a lot of wind. And what I noticed most though, as you might hear in the video, when I stepped out, when it was pretty close to us, I said I can smell it, because that's what I noticed more than the sound of it. the air was just so pungent. It was so potent with kind of a manure smell, an earthy manure smell. And that really stood out. As you could see, the ground scouring from this tornado was pretty extreme. So it was really ripping up a lot of those fields. Yep. And just mixing up the, you know, the farm smells essentially. And that's what it smelled like. I was surprised because I've never been in that situation where I could actually, it just smelled different. So that was what stood out to me more than anything.
Yeah, absolutely.
All right, we are going to go into a Q&A session. Just want to mention again that if you're out there chasing or spotting, just to remember those reports to the National Weather Service can be very critical, like on this day, because the storm was so far from a radar site. It was hard to really analyze the radar based on where that storm was located. So call in those reports when you see something, even if you're not completely positive. It's always good for them to know what you are looking at. As far, you know, you can take a Skywarn class if you're not familiar with what you should be calling in. But in this day, calling in those funnels was really important so they could get that tornado warning issued quickly.
Mm-hmm. I want to start with a quick question, if that's okay, from Mary, who wants to know, what are the chances of seeing a tornado on the triple point of a particular setup? And, you know, I don't know the statistical data beyond or behind that as far as, you know, how often tornadoes are produced on the triple point, but I do know it's one of my preferred areas as far as chasing goes. It's definitely what I tend to kind of preferentially target, but there's a lot of complexity sometimes with triple points because there can be, like you said, you know, convection and cloud cover. Sometimes you have to deal with messy storm modes on the triple point, not always. Whereas further, like, you know, I love also chasing on the dry line because further down the dry line, you're typically a lot more likely to see isolated storms, more classic supercell structure that's not, especially if you're like at the tail end of a storm, you know, the more of that rain-free, beautiful sculpted storms that I love to see and photograph, such as the one behind me here. So that's typical. But triple points can be really good tornado producers because of that enhanced convergence and vorticity in the vicinity of the triple point.
I see another question here. What is the minimum storm relative helicity value that's needed for a decent shot at a good tornado, in your opinion? I'm going to step out for 1 second. I'll be right back if you want to go ahead and answer that.
Sure. I'd say the standard, if you're looking at the 0 to 1 kilometer level of the atmosphere of the sounding, you're looking between at least 100 to 150 meters squared per second squared is what you would kind of want to see in the low level, the surface level, the 0 to 1. And then 0 to 3, typically you want to see 250 meters squared per second squared and above. I mean, these are just very general guidelines, and tornadoes certainly can and do occur below and above those thresholds, but that's kind of like a generally accepted minimum for SRH values in the 0 to 1 and the 0 to 3 kilometer level. So, and then Matt Burt wants to know, rookie question, I guess, what is the triple point? And there's no stupid questions or anything like that. You know, this is stuff that me and Melanie have been studying for years, and we you know, I've gone to school for this stuff for years. So don't hesitate to ask any questions that you do have. Triple point is essentially the meeting point between 3 different air masses. You know, you have your warm, moist air mass that comes up from the south and southeast, and then you have your kind of drier air mass that's coming from the southwest, and then your colder air mass that's coming generally from the north and northwest. So where those 3 air masses meet, that's your triple point. So you'll see kind of your warm front extending off to the right, your dry line extending generally to the south, and then the cold front behind the dry line extending to the southwest generally. And so the triple point is the area in the warm sector that's kind of just outside of the conjunction of those 3 different air masses. And I don't know, Melanie, maybe you can pull that slide up again that shows that triple point area if you want to. You don't have to. but it just kind of shows people where.
Yeah, and when you're looking at surface observations, you'll see the triple point based on where the boundaries are intersecting, and often where there's that low. Do you want this slide or a different one?
Yeah, I mean, that works.
This one?
Yeah.
So they're not showing us the cold front here that's extending south of that low, but it's there.
Well, it's extending to the southwest there. You can see it there. Yeah. And then yeah, and then the red, the wavy red is your warm front there, and then triple point is essentially where the low pressure is, just kind of off to the east of that.
Great. And I see a question here. Do the storm reports need to be called to the National Weather Service covering that area, or should it be to a local law enforcement or 911 call?
All of those can work, really. I mean, 911 is, especially if you don't have time to just search your local, like whatever the NWS office is closest to you, you know, 911 always works. I mean, don't hesitate to call 911 if you're in an area you don't know what the nearest you know, service area is. You can just call 911. That is definitely not a bad approach at all. But if you happen to know the local reporting line for the National Weather Service office that's nearest to you, then definitely call that. But I mean, it doesn't hurt to call in to as many sources as you can. And even if you have, you know, Radar Scope and Spotter Network, you can submit reports directly through those platforms as well.
Right, and some people, not everyone has the number to call. If you go through Skywarn training, skywarn.org, then I understand you'll be informed of how to contact the National Weather Service via phone. There's also ham radio operators. And you can also, this is not the best way to report, but sometimes in a particular situation, sorry, the screen went black here.
You can probably end that unless you want to.
Yeah, you can tag the National Weather Service on posts to social media. So whether it's on Facebook or Twitter, like in Minneapolis, it's, you know, MPX Weather, or Twin Cities National Weather Service, for example, NWS, Twin Cities, MWS. So just knowing those handles, being able to have those connections and the information beforehand is helpful to know, especially if you're going to be chasing a certain area. Find out what their Twitter handles are, and you can tag them in a post real time, that sort of thing as well. Even if they are not able to monitor while the storm is happening, the best way to report, as I have been told, is to call to get that information, or use ham radio, because they're not always monitoring social media, depending on the day, depending on how much staff they have. But it's still helpful for them later as well. So even if you post pictures later, if they're putting together an analysis of the day or doing some reporting from that day, they'll find information on Twitter and social media of pictures and just reports from people that were out there looking at these storms. So that's always interesting as well.
Yep, absolutely. Tim Walsh wants to know, what are the most important parameters for tornado initiation? You want the long or the short answer?
Well, that could be a whole class. So yeah, I mean, let's do the short answer.
The very basics you need are moisture, shear, and instability. So if you have enough of all three of those things, and shear is really, really critical, because that's the turning of your winds and the changing of wind speeds with height in the atmosphere. So as you're going up in the atmosphere, your winds are changing speed and direction as you're going higher. So you need that change in order to promote storm spinning, you know, promote the development of that mesocyclone, which then, you know, initiates the tornado development later. So initially, those are the three kind of classic things that you need.
And oftentimes, you know, it's not always the case, but oftentimes we end up seeing tornadic supercells along warm fronts, dry lines, near that low pressure, that triple point, because that's where all those parameters are coming together to create that type of a storm. Mm-hmm. It's not always the case. You know, you can get some storms in the warm sector where there's a lot of shear. And in other situations, it's so interesting because there's so many different types of systems. I mean, this year I ended up seeing tornadoes, obviously on this classic supercell setup, as well as in the quasi-linear convective system. which is a little more challenging. It's a lot more rain, a lot more merged storms that are a little bit more linear. There's some linear and there's some embedded mesocyclones. So there's a lot of different situations in which it's harder to know if you'll see a tornado or not, but you get most of your classic setups along the warm fronts, dry lines, and near that low or triple point often.
Yeah, exactly. And yeah, Kevin Crowley added the Dr. Forbes acronym of SLIM: shear, lift, instability, and moisture. Yeah, so lift is definitely a key thing too. You know, just having that source of forcing that causes storms, you know, that allows storms to be pushed up and lifted to the level of free convection. But again, that's getting into some more technical stuff that we will get into later. So, but again, that's kind of just the very basics of it. So yeah,
I like that. Yeah, that acronym SLIM is great.
That's a good one for sure.
Yeah, that lift is created at all different levels in the atmosphere, surface and upper levels.
Yep.
So yeah, those are it's really interesting to take a look at more of the details behind the parameters, and it's fun, it's great, it's important to really understand what's happening in the atmosphere in order to be able to read the data and understand where you want to be, what area you want to target for the best storms that day. Because like, sometimes you can have more than one area, more than one target area. And as you can see on that day, there was quite a lot going on in Nebraska too. I've been out chasing on days where I was in the same area actually with Brad one day, and then he and his wife ended up chasing. They drove all the way back to Minnesota from like southern South Dakota, way up into northern Minnesota, to chase up there the next day. And I decided to stay in southern South Dakota in the same place. We ended up seeing similar types of storms that day, but yeah, you can have different, you know, target areas, and just deciding where you want to go, where you want to chase. It can be, you know, you really want to understand what you're looking at in order to determine that.
Yeah.
Determine your target.
So that's why I like doing these case studies, and I'm excited that we're going to be doing more of these. So we're definitely going to be offering more of these going forward. So, and again, along with classes, forecasting education, things like that, that Melanie will probably talk more about. But
yeah, we'll be sharing more soon. Just want to say thank you, Wesley. He said, thanks again, ladies, you rock. Looking forward to your next guest. Oh yes, let's share. I know we've shared this already, but yes, go ahead, and you tell everyone.
Yeah, very excited to be having Skip Talbot on the show with us this coming Tuesday at 7 p.m. Central. He's just someone I really look up to in the chasing community. He's done just a tremendous amount of research in the field, as well as just a lot of really incredible storms that he's documented and really exhaustively studied and researched. And so we're excited to chat with him and get his insight on some of his recent research, some of his career successes, anything like that he really wants to talk about. So we're excited to pick his brain on Tuesday. So be sure to tune in for that.
Great. Yes. There's another question from Mary asking, does the cap have to be blown off for the storm to become tornado warned? And so when we're talking about the cap, it's, do you want to explain that just kind of in a basic way?
Yeah,
it's an interesting term for what's actually happening in the environment.
You know, yeah, the cap is just essentially acting like a lid on your environment. So it's good in that you initially want some capping. Cap is essentially a layer of slightly warmer air that, you know, kind of prevents storms from rising, because typically, you know, temperature decreases with height in the atmosphere. Well, if you have a layer of warming, typically about the 700 millibar level or a little bit lower, but that can shift. That essentially acts as like a lid to stop storms from forming too early in the day. But if you have too strong of a cap, then storms will never be able to break through it. And so then storms don't develop. So there really is it's just a fine line, a fine balance of having capping enough to, you know, allow storms to have enough time in the environment to become, you know, for the instability to really build up.
Yeah.
Without having too much capping to prevent storms from going up. But that's another concept that's more complex that we'll be going into later. We don't have a lot of time to really go into some of the really complex stuff, but we will definitely, so stay tuned for our classes because we're going to be doing a bit of that as well.
Yeah, the cap is, like Jessica said, like a lid holding things down. So it essentially, I like the way she's saying this. It doesn't have to be blown off for the storm to become tornado warned. Well, actually, the cap has to be penetrated, essentially broken through by this rising parcel of air. It has to break through the cap, because the cap is actually a more environmental thing. It's not just associated with that storm. So when you get the air that actually is able to get through that cap and rise because of the lift or a little bit of cooling happening up there, then so essentially you've got something coming through the cap rather than the cap being blown off. You're just kind of punching a hole through the cap in that area, and then that storm develops. So it doesn't even mean it will be tornadic. I just want to mention that too. When we talk about the cap or the cap breaking, when the cap breaks and storms are able to develop, it doesn't even mean the storm is going to be tornadic. So it really doesn't have to do with the tornadic aspect of the storm, if that makes sense. But it does have to do with storm development and initiation.
Yep. Yes, ma'am.
All right.
I think we should wrap it. What do you think?
Yeah, I'm not seeing any more questions. Somebody's saying something about 2018, but that was a different question. So, yeah. All right. Well, we really appreciate you joining us today for this case study. It's just been so fun to walk through this data and take a look at the day and learn what we can from it. And I hope that you all learned something too, and at least got a nice overview of what happened that day, so that one important thing is to be able to develop pattern recognition skills. So as we see similar days in the future, we can say, oh, that reminds me of this day. And then you can start to make some decisions based on that pattern recognition, like, oh, that happened this day. Maybe it'll happen again the same way. Exactly. It doesn't always, but sometimes it can. So that's another advantage to really going over these case studies. Even if you know some of this information, it just really helps remind you of certain things and to develop more of that pattern recognition.
Exactly. Yep. Critical skills to have as a forecaster and chaser, just in general. All right. I think we're going to wrap it up for tonight. And Kevin says, thank you for the afternoon chat. Mary says, you girls are awesome. Matt says, thank you, ladies. So yeah, thank you guys again. We appreciate you tuning in, and make sure, feel free to continue to ask questions if you'd like, even after we end the chat. We'll try to get to them when we can. But in the meantime, just go ahead and make sure you tune in for our next Tuesday show.
We'll talk to you soon.